Hello and welcome to Chemistry Lesson 3.01, Isotopes. This is the first lesson in Chapter 3 titled Atoms and Moles. In this chapter, we're going to look at how do we measure masses with elements. Can we change the number of neutrons and it still remain the same element? Where do the masses on the periodic table come from? And finally, if I have a mass of copper sitting on my lab bench, can I tell how many atoms are in that? And the answer is yes. And we're going to learn how to do all of those things in this chapter. So it's going to be a more mathematical chapter. Maybe you're glad to get back to that. Maybe you'll be glad to go on to a chapter that has less math. But our first topic is isotopes. And to talk about isotopes, we need to review a little bit about protons and neutrons. So we learned in the last chapter that a proton has a symbol of P plus, and it has a mass. Well, actually, it has a mass of, it's like something times 10 to the negative 27th kilograms. We said we're going to give it a mass of 1, and that's 1 atomic mass unit. We actually said it was a count. We said the atomic mass is the same as the number of protons and neutrons in an atom in a nucleus. And neutrons have N with a 0, and they have the same mass. So atomic mass unit is AMU. Turns out that's a completely made up unit. So we looked at, again, the actual mass, which was 10 to the negative 27th kilograms, like 1.2, something like that. Scientists got really tired of writing all of those exponents all the time. They said this would be a lot simpler to work with if we could just make a proton worth a value of 1 and a neutron worth a value of 1, and we'll give it a name like an atomic mass unit. So we know that protons have a mass, this mass of one of these, and a neutron has a mass of one of these. And if you add up the protons and neutrons, because their masses are 1, that is your atomic mass. The atomic number is the number of protons, and we learned that in the last chapter. So we're going to start off and we're going to talk about lithium. So to start with, you should all have a periodic table by now. Get your periodic tables out and look up the atomic number for lithium. All right, hopefully you saw that it has an atomic number of 3, which means we're going to draw out nuclei here. So I'm going to draw a nucleus. I'm going to start over here, and I'm going to make my protons red. So we'll do P plus are red, and we'll do neutrons equal a red circle. And we'll do neutrons as a green circle. So the atomic number for lithium is 3, so that means I have to have 3 protons in my nucleus. And I also have electrons around the outside. I'm not going to draw the electrons in, but if we have 3 protons, for now we're going to say, yeah, I better draw my electrons in. I'll draw them in this first time. And I'm drawing these about the same size as the protons, which is highly inaccurate because we said the electrons barely have any mass at all. So you might say, well, if I've got 3 protons, I must have 3 neutrons. And you would be correct. This is going to have a mass of 6 because I've got 3 protons and 3 neutrons. My first question is, can I change my number of protons and have this still be lithium? So what happens if I take away a proton? Hopefully you said, no, that won't work, because if I do that, that's going to give me helium. Helium has 2 protons. Remember, our protons are our identity. They're what determine what the element is. Can I change my neutrons? Well, that's another question. So let me redraw a nucleus. I'm going to do 3 protons again, and I'm not going to draw my electrons this time. But what if I go with 4 neutrons? And my electrons are there, they're just around the outside. Is this allowed? And the answer is yes, it is. In fact, not only is it allowed, it exists. This has a mass of 7. Can I change it again? Like how? We still have to have 3 protons. Could I do 5 neutrons? This would have a mass of 8. And here's the thing, the answer is yes, you can. These are 3 different forms of lithium that all exist. Now, it turns out this is the most common. But we have some of this and we have some of this. When we have different forms, so different forms of the same element that vary by their atomic mass, we call those isotopes. So the definition of an isotope are different forms of the same element that vary in their number of neutrons and as a result their atomic masses. So these are the isotopes of lithium. Well, you might be looking at your periodic table, and you'll notice that your periodic table doesn't say 6 or 7 or 8. The periodic table actually says 6.941. There's a reason for that, and that's our next lesson. So don't worry about that yet. But it's really common for elements to have isotopes. So if we looked at hydrogen, let's go to purple, and let's go to hydrogen. How many protons does hydrogen have? Hopefully you said 1. There are 3 different forms of hydrogen. Let me bring this guy over here a little bit. White this out. Get my whiteouts out. The most common element, the most common isotope of hydrogen has 1 neutron. This one has 2. Remember, this doesn't exist. Sorry, that's couldn't find my whiteout. And there's another one that doesn't have any neutrons. These guys actually have names. This is called protium. This is called deuterium. And this is called tritium. And this is the most common. Do I have electrons? Yes, they're circling around the outside. Tritium, let's see. There we go. So these are the 3 isotopes of hydrogen. You can have no neutrons, you can have 1, or you can have 2. So my atomic masses here are atomic mass. I have 1, 2, and 3. And these all exist, but they exist in different amounts. There's always usually one that's more common. Well, there's a couple of different ways that scientists write isotopes. So we have what's called isotope notation. And I think I'll switch to blue. We have the first way is called AZX, or we can do hyphen notation. Hyphen notation is probably the easiest. So for hyphen notation, I would write this as lithium -6. I would write this as lithium -7. I would write this as lithium -8. So it would be hydrogen hyphen 3, I'm off screen, let me do this one, hydrogen, hyphen 2, so on and so forth. If I was going to write this in AZX notation, the X is the element symbol. The Z is the atomic number. And the A is the atomic mass. So if I was going to write lithium 6 in AZX notation, I would write this as lithium 6 and the atomic number is 3. If I was going to write this, I would write lithium 7, 3, lithium 8, 3. Hydrogen would be 1 and 1 because I have 1 proton, that's it. This would be hydrogen 2 and 1, hydrogen 3 and 1. All right, finally, let's look at a sample problem and see if we can solve. So if I looked at mercury, let's try to squeeze in a sample problem here. If I had mercury 280, and I wanted to know how many neutrons I have. Remember, this means that I have mercury. I have 80 protons. This is my mass, which is my protons plus neutrons. So 200 minus 80 is going to give me 120 neutrons. All right, that is a brief explanation of isotopes. Thanks for watching and have a good day.